Good morning, student, or good evening. What we are going to talk about today is the concept of data capture and storage. Okay, so what do we intend to do today in data capture and storage? By the end of this class, you are expected to understand what a survey is, what web scraping is about, what an API is. All these are the different concepts that we are going to cover today. And then, obviously, whatever I'm covering today, I will just go very lightly in terms of some practical aspect of these different things that I'm going to mention today. But nevertheless, we will get in the details of how to work with APIs and how to do some basic how to do some web scrapping rather next semester, next week. Excuse me, not next semester, but next week. We're going to talk about that. And I will also explain to you the concept of what we refer to as a relational database. In the relational database, you will learn different things that we will refer to as tables. You will understand how to create a table. You will understand the concept of a key. You will understand the concept of constraints. You will understand the concept of constraints. You will understand the concept of acid, what this means. I will talk about that. All these are different things that I might be mentioning today. I will not might, but I will be mentioning today. And then I will also talk about the how to write simple SQL statements, okay, like SQL select and so on to create a basic database. I will talk about that today, and I will also explain the difference between these different files. So what are the differences between the CSV file, the JSON file, and the Parquet file. All these are going to be mentioned. Of course, I will pay emphasis, especially today, on the JSON file when I'm going to give you an introduction of how you can create a JSON file and so on. Okay, so that's a little bit in a nutshell what I intend to do today. To start with, we'll talk about data capture. When we talk about data capture, we are talking about the lawful acquisition, as you will see here, the planned, lawful, and documented acquisition of raw data. And these raw data come from different sources so that it can be stored and analyzed. Now, how can we capture data? We can capture data through surveys. We can capture data through web scraping. Now, we will talk about web scraping later about the different aspects of web scraping because there is something that is important here, which is if permitted. And then we will also be talking about APIs. These are different ways that you can capture data. Now, when we are referring to capturing data, an example would be if you are talking about a survey, you will normally talk about how do we. There are different surveys that are done. You can ask people different questions, and we'll talk about different aspects of surveys in a moment. There is the aspect of API where you can use, for example, you can use data available from World Bank to scrap data through an API. You can also use the concept of web scrapping to scrap price list from a website, for example. Donc, what are the differences between all these? We'll get into that in a few minutes. So, first of all, we'll talk about a survey. When we talk about a survey, what is it about? Normally, when we are referring to a survey, they are going to be something you are going to collect data from scratch using a survey. You can use a sort of forms, you can use questionnaires and so on to collect data, generally from a sample. That's what we refer to as a survey. And when would you normally apply? When will you go for a survey? It's especially when data is normally not available. That's why you would go for a survey. No. If the data is available online, generally we'll use the data as long as it matches your definition. The strength of a survey is that obviously it suits your purpose, that you're going to design custom questions that will suit your purpose. And then you have control over what you are defining in these questions. And also you have control over timing, how many minutes you want the survey to be carried out, how much data you want to collect, and so on and so on. The limitations of this survey, obviously, it is time consuming because there are um, the time of collecting data from one person, maybe 20 minutes, 30 minutes per survey. And imagine doing that for, let's suppose, a sample of 1,000 people or even 300 people, let's suppose 300 people. That takes some time. Of course, there are different costs associated with the survey. When we talk about cost, there are different costs, transport costs, probably there are other different costs related to the survey, like you need to pay an interviewer for to do the survey. There are limitations in terms of non-response. Not everyone would generally answer your survey, and there is also the issue of measurement error that are limitations of surveys. When we talk about measurement error, there are errors that can occur in terms of wrong coding. There are so many types of errors. So the key steps in a survey, let me just define that before I move on. The key steps in a survey, you start by number one, you define your target population. That's generally how you go about, and of course the frame. When we talk about the frame, it is a list of members in your population as far as you've got it. Not always would you got it, then you will need to go for different other sampling methods that are cluster sampling and so on. But if you've got the sampling frame, you use the sampling frame that is available. The sampling frame is a list of members that you have in your population normally. Number two, you will go for different sampling method, not different, you will go for a particular sampling method. You will go for a particular sampling method. Now, when I talk about a particular sampling method, there are different sampling methods. There are numerous, in fact. There are numerous sampling methods that exist. And which one would you use? It depends on your study. But generally, when we talk about a sampling method, we have a probabilistic sampling, and you have also non-probabilistic sampling methods. When we refer to probabilistic sampling methods, you have different methods like the SRS. SRS means simple random sampling. You have stratified random sampling. You have also cluster sampling, which is part of the probabilistic methods. You have also something else that we call a systematic random sampling. All these are different probabilistic methods. You also have non-probabilistic, obviously. Non-probabilistic in the form of quota sampling. You have non-probabilistic in the form of convenience sampling. You have snowball sampling. All these are different sampling methods that exist that you might have to go through when you're collecting your data. Number three, you have to take into account the questionnaire design. As I told you earlier, it depends uh, how long you intend to take in with a with an interviewee. If you intend to take, if you are able to take 30 minutes, you might ask many questions. But if you intend to spend only 5 minutes, obviously you will design a question that is relatively short. Designing a questionnaire is in itself a whole process behind. So that's one thing. The next step generally that you can go through is you can go through a pilot study. When you've designed your questionnaire, when you've decided on your sampling method, which also I forgot to mention here, which is the sample size that needs to be taken into account. When you've decided the sample size, you've decided the sampling method that you are going to adopt, and you have already designed your questionnaire, before you decide to really go on the field and start collecting the data, uh, like we'll say capturing the data, maybe one of the things that you want to do is to do the pilot study. The pilot study, the idea behind the pilot study would be normally to have some information with regards to the questionnaire. You will go for maybe 3 or 4 people, or let's suppose 10 people, and then you would administer that questionnaire with 10 different people. And then you will ask these different people about these different questions that you ask. And there you will have issues that you might find with regards to your questionnaire that you might address before you start before you start administering your questionnaire to the whole sample. So in the pilot study, normally you will identify issues that exist while in your questionnaire, and you will address these issues before you go for the fifth step, which is your field work. Which is your field work. Now, when I talk about field work, I'm talking about now going on the field and administering the questionnaire. Now, you will need to train your interviewers and so on and so on. There are many aspects about that. So you need to go and collect the data use on the field work, and this is important that when we refer to the field work, you have given proper training to your interviewers so that they don't bring in, for example, interviewer bias and any other issue. Then, of course, when you have gone to the field work, the next step would be to this part, which is relatively important to us. It is the data entry, and also data entry, where now you are going to save these data. You are going to capture these data that from the questionnaire and input those data on, for example, an Excel sheet or any other software, uh, depending on the context. When I talk about going and inputting the data, it depends if you are using already a tablet, for example, to collect the data. Maybe if you have a particular software to collect the data, that is when you are recording the um, different responses from the interviews, then the data are captured automatically on the tablet, and sometimes this saves you the time of going for data entry. But if you are going to do a physical survey, then you will have to go for data entry, where you ask a person to input these different data on your computer. Okay. Now, these are the different things that we can talk about a survey. And when we talk about the questionnaire design as well, we need to be very clear that this is a very important part, the questionnaire design in the survey, where when we talk about a questionnaire design, we need to ensure that our questionnaire design does not bring in bias in any way, in any form, should not bring any bias. What do I mean by any bias? For example, when you're designing a questionnaire, you need to ensure that the questionnaire is well defined, well designed in many ways. For example, you need to know what type of questions you are asking. In a questionnaire, you have questionnaires. You can ask single choice questions. You can ask single choice. Either the person replies by yes or no, for example. But you also have other possibilities where a person can answer from multiple choices. All right. For example, if you ask them, what car do you have? And a person tells you he's got a car BMW, and he's got a Mercedes, he's got a Toyota, for example. Maybe the person has got all the three, then it is a multiple answer that is possible. Okay, multiple answers possible. Then you have also a Likert scale, for example, your level of satisfaction, strongly dissatisfied to strongly satisfied. It starts from a scale of, when you talk about strongly satisfied to dissatisfied to strongly satisfied, start from one being strongly dissatisfied, then it becomes two. dissatisfied, 3 is neutral, 4 is satisfied, and 5 is strongly satisfied. This is a Likert scale, we refer to that. And then you have numeric answers where a person can record his age. For example, he will say that he's 22, he say whatever age he's mentioning. This is a numeric sort of answer. And then you have verbatim. We refer to that as verbatim or open text question, where a person can record verbatim what the interviewee is stating, especially if you are recording the opinion of a person with regards to a certain topic. That person may be telling you quite a number of things, and you're just going to record this verbatim. So these are the different things that I refer to as types of questions that you can set. And then, of course, there is the ordering of the questions, which is important when you are setting the questions. For example, if you have a question where the salary is important, you will not start by asking the salary of a person right from the start. You might wish to ask the question of salary at the end. By the time the person get some confidence with regards to you, and so on and so on. There are different things that you need to take into account when designing a questionnaire, and also it is important that you do not include bias. There is something that we call an interviewer bias, for example. There are leading questions, there are non-response. For example, let's suppose I'm doing a study on sexually transmitted diseases. Let's suppose sexually transmitted diseases, and I come to a person and I say I'm going to do a study with sexually transmitted disease, and that person asks you, what does this mean? And then you start by mentioning that there is, for example, AIDS, which is an example of a sexually transmitted disease. Then that person, when you have, as interviewer, you have already told him what a sexually transmitted disease is. And then in the first question of your questionnaire, you would say, do you know what a sexually transmitted disease is? That person, the fact that you have already guided that person to what a sexually transmitted disease is, in when you have the answer yes or no, instead of saying no, that person will say yes, because you have already mentioned to him what a sexually transmitted disease is. For example, AIDS. You mentioned that. So this is a problem. When the person should have answered no, it means that he did not know, in fact, but you just guided him. This is what we call a leading. You have interviewer bias, for example, here. And then, of course, there is a concept of ethics where you need to ensure that there is consent, anonymity, secure storage. You remove any direct identifiers when you have recorded the data. If you intend to publish the data to make it available to people, you need to ensure that there is anonymity, remove any identifiers, which is a bit related to anonymity. But there is also the issue of consent. For example, if you are doing a survey among young children below 18, you can't just go and start collecting data from young children. You might need the consent of their parent and so on. And there are also ethical aspects behind if you are doing a survey in a college, for example. So these are a little bit about surveys, question design, and bias. So what are we going to do next? Now we are going to talk about web scraping. What about web scraping? What is web scraping? Now, you will see here the definition that I've set here, that web scraping is the automated collection of data from publicly available web pages by downloading the HTML and related resources and extracting the needed information with a parser. It differs from crawling, which mainly discovers or visit links, and from APIs, which serve directly in a structured format. But just for information, when we talk about web scraping and API, there is some direct similarity between these two. I will discuss that in due time. But right now, when we're talking about web scraping, what basically you are going to do is that you are going to go to a website and collect information from that particular website. That's basically what it is about. You're going to collect relevant information that is required, that is important for you. It can be text, it can be numbers, it can be many things, but whatever you want to collect. Now, of course, there is the ethical aspect behind ethics and legality first. If disallowed, you don't do any of these web scrapping, right? If you're not allowed, you are not going to do the web scrapping. Anyway, we'll talk about that in a moment. But what matters here is that you need to understand when we are referring to contents from HTML, it can be table, excuse me, it can be table list, it can be free text, it can be attributes, it can be links, prices, even embedded JSON file. What is JSON file? I will get into that in a few minutes. All these are things that you can get and extract from HTML, from a web page, basically. Now, one thing that you need to understand when you are doing web scrapping, if one day you will have to do some web scrapping, which is ethical and legal, obviously, you have to understand that web scrapping works quite well with static pages, and it doesn't work that easy. It is not so straightforward when it comes to JavaScript rendered sites. Okay, it is not so straightforward. What's the difference between these two? I'm not going to do a course on HTML language or websites or and so on. But basic difference that static sites are excellent generally for um, content heavy, where you have less dynamic websites where security is very important. These are static pages where security is essential, where you have the content of the web page is heavy. Normally, you will usually use a static page because it's about how the server is loaded or open on the not server, but how the page is open on the server. I'm not going to get into all these details, but just for information, uh, I will give you an example of two and explain to you what the difference is between these two. There is another kind of websites that open through JavaScript, and the difference here is that JavaScript rendered sites normally, what they are is that they are very interactive. All right, they are highly interactive. Generally, you get it into web applications where the user experience is a priority. You want to get information about the experience, the user, for example, his name, and so on and so on. It's very interactive. Whereas static pages are not interactive. Generally, they are just plain there. Uh, there's not much interaction going on necessarily. Now, when I refer to JavaScript and static pages, let me just give you an example to show you of two relatively well-known static pages. Let me just open that and show you, just a minute with you. Here we go. Number one, I've gone to my privacy setting here, and you will see that under site control there is JavaScript. I click on JavaScript, and then you will see that there is a default behavior of your browser. I'm using Chrome here. The default behavior is that sites can use JavaScript. All right. Let me show you, for example, here. I go to Twitter or X now. You will see that when I load the page, it takes some time to load, but you will see that it's loading and it works perfectly well. You just need to sign in and so on. I do the same thing for Wikipedia. It works perfectly well. You will see that there's no issue about that. You will see that one of them is JavaScript rendered, and the other one is just static HTML page. For example, Wikipedia is normally the static embedded, uh, not embedded, but rendered site, whereas Twitter or X here is normally a static, not a static, but rather a JavaScript, excuse me. The Twitter is JavaScript. The Wikipedia is normally a static page. I repeat, sorry for the confusion here. Wikipedia is a static page, whereas this one, Twitter, is a JavaScript. How would you be able to get to know that? For example, you can just easily go on the setting JavaScript, and you just disallow that. Don't allow sites to use JavaScript. And then you go, for example, to Wikipedia. I reload that. I do enter. You will see that it reloads perfectly well without any issue. However, when I come here and I do enter, reload it, you will see that normally it will give me an error. It will tell me that JavaScript is disabled. So you already have an idea which website is JavaScript rendered and which one is not JavaScript rendered. So I put it back to the default, which is the sites use JavaScript. I do enter here. You will see there that it is working perfectly well now, as you are seeing, and even the Wikipedia anyway, it will work naturally well. So this is a brief difference between these two. So in other words, that already tells you something. If I want to scrap information from Wikipedia, it will be relatively easier than scrapping data from Twitter, for example, because here Twitter is a JavaScript rendered file. So web scrapping here would work far better on Wikipedia. It's easier on Wikipedia than the JavaScript uh, Twitter file. Now, the other thing that I just want to mention is that I've also said that the web scrapping is about collecting the data from web pages and extracting the needed information with a parser. Now, when we refer to a parser basically, if you want, it is a software. If it is a software, all right, there are different software that exist that are parsers that normally they read text, they read even HTML files, they read JSON file as well, and they turn it into a structured in-memory object. Structured in-memory object that you can use, that your code basically can navigate and query. I'll just give you an example of a parser that you will use later in a moment. I will show you that in a few minutes how to scrap some data. So you will use, for example, R as your software, but R is not the parser necessarily here. R is a software, and in R there is a package, for example, that you can collect data from a JSON file, for example, which is JSON Lite that you can download. This package is in fact what we would refer to as a parser. Okay, uh, basically it will convert your JSON uh, data, your JSON information into an R object, all right, like a list or a data frame, and you can use that list or data frame to do your analysis. You can't do an analysis using JSON file as it is. You will need to use that parser. For example, our parser in R will be the JSON Lite. So that's what we are going to use. Now, before I move on, there is something that is essential is that when you are going on a website, before you do web scraping, you need to ensure that the rules of the website allows you to do such things. You cannot go on any website and start doing scrapping. This is not ethical and not legal as well. You have to be very careful about that. For example, there is something that we call a robot.txt file. That is important that you go and check what this robot.txt file includes. I will show you in a moment an example what I'm referring to by robot.txt. So some website like for example Wikipedia may give you the permission to crawl in the website, or may give you also the permission to scrap data depending. We'll need to check that in a moment. You will see that. And then you need to also look at the terms of use, which is a legal contract between you and the website manager, for example, here, the website company that you are using, the website of the company, basically, for example. And then the copyright also, which is important, especially when it refers to images or multimedia. There are copyright issues. For example, you can't use a multimedia and make as if it is for you. These are about copyright issues. All these are to be taken into account before you scrap a data and use. Sometimes you might be allowed to scrap a data, but you are asked, based on copyright issues, uh, to mention and acknowledge that person who has produced that image or anything like that. So now what I'm going to do is to give you an example of what I refer by robots.txt. All right. So what we will do is that we will click on this interactive display here, this image. I'm going to click on it and it will give me a web page here from my GitHub repository. And we are going to talk about robot.txt. What do I mean by robot.txt? All these are important before you do any web scraping normally. That's very important. Before we talk about robot.txt, I just want to uh, remind you about the concept of web crawling and web scraping. Just remember something, that when we talk about web scraping and web crawling, though they are in certain ways not really similar exactly, but they have some kind of similar function, because when you are doing web scraping, you are partially going through crawling, but uh, there's a difference between these two. Web crawling basically is like you're sending a robot that we refer to as bot generally. And the idea, normally when I talk about bot, it's also referred to as spiders that you send on the internet, that you send through the internet, that this robot or this spider will walk through the internet and collect URLs. URLs means, for example, it will collect these website URLs. All right. What is the end result of web crawling? Generally, the end result is a list of pages that you get, a list of pages and their links that you get. The purpose generally is normally sometimes there are competitors who want to crawl and check the websites of other competitors. Sometimes they would like to see if they are in the business of, let's suppose, chicken business. They may be doing a search, a web crawling on all businesses and their competitors, I mean, and then they go and see which websites are open, which websites exist, which website doesn't exist, and these are the kind of things that exist in web crawling. Normally, Googlebot is a very well-known crawler, and Googlebot is an example of a crawler that visits millions of websites, and through that crawling exercise, it can build what we call the Google search index. These are about crawling. But when we talk about scrapping, generally, we are referring to normally visiting a specific page, but more importantly, about copying down information from that page, extracting information from that page. But crawling does not necessarily do that. It just collect these URLs basically most of the time. So when you are doing web scraping, you may go through web crawling before going through web scraping if you want, unless you know the URL that you want to scrap. That's a different story. But if you don't know the URL that you want to scrap and you want to scrap data from multiple sources, you might wish to go through web web crawling first. And that's a little bit different. So basically, like, crawling is telling you where to go, and scrapping is like once you know where to go, you get there and get what you want from that place. Okay, that's a kind of difference. So crawling is like making a list of, if you can say it like that, you go and make a list of all houses in a city, in the city of Catrobon or things like that. And then scrapping is like knocking on the door of these individuals just to write down the furniture that exists inside. Okay, You are going to collect information pertaining to what you have inside the house. Okay, so crawling is like knocking on the, making a list of all the house, and scrapping is knocking on a house, on a house, and then at the house, and then you take the information regarding what furniture that this house has. That's a little bit the kind of difference that we have. So this is why I'm telling you here, an important consideration is that robot.txt governs crawling, fetching URLs, but not data reuse, in other words, in terms of scrapping. However, because scrapping almost always start by fetching pages, you should treat robot.txt as applying to scrapping as well. So this is why robot.txt is very important um, information with regards to whether you are allowed to do some scrapping or not. You will see here I've given you a few examples of two examples of well-known scrapping tools. You have Google robot.txt that you can go and click on the link. You will see that this gives you a list of things that are allowed and things that are not allowed on Google search engine. In the same vein, you will see that Wikipedia, you will have a list of things that are allowed and things that are not allowed. Generally, you will have user agent. You will see sometimes you have things that are informed here, disallowed, allowed, slash, things like that. What are all these? I've explained through this interactive plot here what they mean. I've taken only the example of Google's just to give you an indication. It's not we are not going to take too long on that, but just for information. For example, you will see that from a general example, when you see user agent and then you see the star is like a wild card, which means that it applies to all web crawlers. For example, there are certain web crawlers that are allowed, like user agent. If you click on a generate example, if you see user agent, it says Googlebot. What does it mean? When it's a user agent Googlebot, it basically means that Googlebot is allowed to do certain things. Googlebot is allowed to do certain things, but it is not allowed to, for example, it prevents it from crawling internal searches. This is what happened for Google, but it allows it to do many things, but it doesn't allow it to do to go on the slash search. When I say slash search, for example, when you have a URL like this, you will have several things, and let's suppose I had slash search. It doesn't allow the bot to go there and do search results of pages. Obviously, that would not make any sense to do that. Otherwise, it will become a problem if Googlebot was allowed to do a search, an internal search within that website, because they don't allow that. Otherwise, it get into private information and so on. Maybe an example. I'm just taking an example which is generic. Then you have Bing bot, which is another bot which is known, but you have certain things that you can allow for Bing bot. But then for all uh, crawlers that comes in, irrespective of what they are, there are things that they are not allowed. They are not allowed to do to go and get information from slash admin. All right, this allows disallow directive telling crawlers not to access specific path, and in this particular case, any URL that start with slash admin, the crawlers is not allowed to go through. And then you can glue on that and just to see what these different information may mean when we talk about a robot.txt. What does this mean? I've just given you an example here, so you can click on these different components just to understand a little bit what these different things refer to and what they mean. All right, so we're not going to take too long on robot.txt. That's what I wanted to talk about in terms of robot.txt, but I will move on now to web scrapping. When I talk about web scrapping, remember it is always good to consult this robot.txt, which is, as you see here, at the root of a website most of the time. So, like in the context of, let me just go back to um, this website, just a minute with you. Like in this context here, when you type wikipedia.org slash, it is at the root. of the URL. You got robot.txt directly right from the start. If you go on Google, you see google.com/robot.txt. It's not like google.com and then you have another something else here before. Let's suppose I do search and then whatever. No, it's not like this. So basically, you will get it at the root of the website normally. And that's the first thing that a bot will consult before going and investigating what you have. So this is okay. What I will do now, I'll get into the concept of web scrapping. All right. In terms of, terms of use, copyright, licensing, and so on, what these mean, because I mentioned that in my previous slide. So I will talk about the terms of use, copyright, and licensing. I'll just go over that quickly and give you an indication of what this means. Now, it is essential that when you are doing scrapping, you understand these different terms. What a term of use is, what is about copyright and licensing, and so on. Okay, when are you able to scrap? When it is not allowed to scrap? This is essential before you do scrapping. Otherwise, you may be doing something that is not legal, and you have to be careful about that. We are going to click on the display here, and that shall lead us to a web page where you can get a guide to when you are allowed to do scrapping, when you're not allowed to do scrapping, and so on. So to start with, you have a term of use, which is a very important part, which is a legal contract between you and the website owner. And it's good that you consult this term of use before you do any scrapping. I'll give you a small example here of a LinkedIn user agreement. If you click on LinkedIn user agreement, the LinkedIn user agreement, you can find it in the website normally, but I gave you the direct link here. You will see what are the do's and don'ts of that website agreement. Okay, what are the do's and don'ts? So, for example, if you just search the word scrap, you will have an idea of what is allowed or not. You will see already that scrap is under the don'ts. So you agree that you will not. If you, I'm not going to read everything here, but you agree that you are not allowed to scrap or copy the services. So if you try to scrap and so on, you are subject to legal issues. All right, you should be very careful. This is why it is always important that if you are scrapping a data from a certain website, that you consult the user agreement just to have an idea, which is a term of use of that particular website, to be able to know whether you are allowed or not to do some scrapping. I'm not going to go in the details of all these. You may read it on your own. You will see what it is about. And then you have also some other concepts like copyright and licensing. Now, when we talk about copyright and licensing, it is especially when it comes to image creation, when you talk about how do we say, for example, uh, uh, a video or an image that you may want to use, it is always good that you consult the license. So, what does it mean by the license? Maybe you are allowed to reuse the content, but you may be allowed to reuse it with attribution. What does it mean by reusing with attribution? It means that you may be allowed to reuse the content of a particular website, for example, the image of a website or anything that the website allows you to do. You can use certain things on the website, but reuse with attribution means you will need to inform or you need to cite the author in your report. You can't just use it making as if it is your own. This is an issue of copyright and licensing. For example, you will see that real world example, that is Wikipedia content, is available under a Creative Commons license that requires attribution. It means that if you are using certain things from Wikipedia, whatever you are using there, content, text, or anything, it is always good that you cite the author of that particular content. When I refer to Creative Commons license, by the way, Creative Commons is normally a non-profit organization, and they usually provide free public licenses. Okay, that you can normally, of course, under certain conditions, they allow you to use, copy, distribute, or do whatever you want, adapt the work, but under specific conditions. All right, this is what I mean by Creative Commons. So it's a non-profit organization that provides free and public licenses. All right. So if you click on Wikipedia content, you will see what are the things that you are allowed to do or not. For example, here you see reuse of text under Creative Commons attribution. So to distribute a text page in any form, provide credit to the authors. This is what I mean when we talk about copyright and licensing. Now I'm including here APIs. Now, APIs I'm including here, what does it mean? An application programming interface. And in fact, an API is not is an official way that you are allowed to get data from a website or another program or an interface. An API is the official sanctioned way for programs to get data from a service. That's what I mean by an API. Now, the advantage of an API is that it gives you the leeway, gives you the ability to collect data from the website. I already gave you this example of World Bank API last week, where the API is a way that you can go in World Bank and collect data directly instead of scrapping. So they give you this ability of doing that. It's better to use API generally because when we refer to APIs come in a clean form most of the time. When you look at the data of World Bank, they will come in a relatively neat form, sometimes in JSON format, so that you don't have to parse messy HTML. Remember, when we talk parsing, it's about converting this HTML file in your software in a way that you can use it. All right, that's what I mean by parse. For example, the JSON Lite, as I mentioned to you. So you can read through that, but an API is one ethical and appropriate way of collecting data from any source. If the website gives you the ability to use the API or not, depends. Not every website will provide an API. So the API is a sanctioned way, like the example of a World Bank that I mentioned. So when are we allowed to scrap or not? I gave you a few scenarios here, and normally you are allowed, for example, sites with permissive licenses like Wikipedia, as I told you, allow you to take some text and scrap text and so on. But of course, under certain conditions, don't forget, under the Creative Commons license, it depends if you are using a picture for whatever purpose or a content of a person was posted on Wikipedia for whatever purpose. You need to ensure that you cite that person as well. And don't forget, this is important. You're allowed to use it, but scrap here, but under certain conditions, obviously. And when are you not allowed? Like in the context of LinkedIn, you will recall I gave you the example of a user agreement of LinkedIn. There, you are not allowed. Even Facebook will tell you in the term of use that you are not allowed to scrap or anything. So trying to scrap will lead you to trouble. If in case you are caught trying to scrap in these websites, you're gonna be subject to legal issues. So, in any case, there are certain contents in on Facebook, on LinkedIn, or many other websites, social media, for example, where you won't get information like login details and so on. These are for sure not going to be available for anyone to scrap. That's going to be very, very difficult for someone to be able to get this information anyway. Um, and then there is a yellow light, in other words, be careful. Okay, for example, you have e-commerce sites. I'm not going to mention names, obviously. I don't want to get into trouble by mentioning name here, but you have e-commerce sites where you may be allowed to scrap data, especially if you're scrapping prices and so on. But certain e-commerce sites allow you to do things, but you need to consult the term of use to know what you are allowed and what you're not allowed to do. And don't forget the robot.txt as well, that you need to check to see what you are allowed and what you are not allowed. So these are important. For example, news outlets, you may scrub the headline, for example, of certain newspaper under certain conditions. I'm saying, I repeat, you need to consult the term of use. Maybe some newspaper don't allow that, but at all to scrapping information. But sometimes some may allow some scrapping. For example, you may allow to scrap the headlines, but you may not be allowed to scrap the whole article because of copyright violation, obviously. All right. So it depends. You have to be careful. I gave you some idea of how you can do that. You can, to know if you are allowed to scrap data or not, consult the term of use. Don't forget the robot.txt. So basically, I gave you an ethical checklist here where you start by checking the robot.txt first. You read the term of use to know if you are allowed to scrap or not. And then you check the copyright license also. If you have to, how do we say? If you have to reuse with attribution, you can use with attribution, but be careful. Sometimes you're not allowed at all to use anything. That's also important. But what is more important is to look for an API. If an official API is available, you use that API. If an official API is available, you use the official API rather than trying to scrap data. Okay. When in doubt, on whether you are able to scrap or not, then you can contact the site owner to know if you are allowed to scrap certain data or not. But as I said to you, you have to be very careful when you are engaging in scrapping so that you don't go uh, outside what is allowed or not. That is, you stay within limits. That's very important. Now, what are we going to do next now is web scrapping only for structured data? When we talk about web scrapping, let's suppose you have to scrap some data. When I talk about scrapping some data, are we talking about structured data? Yes or no? You can click on that and it will lead you to a page. There we go. From that page, I will give you an interactive display of whether you are able to scrap data in different forms, whether different types, I mean. There are structured, semi-structured, and unstructured. I also put not non-HTML, excuse me. There we go. So you have structured data. When we talk about structured data, what happened here is that you have different examples of structured data. There are data in the form of tables. There are data in the form of ordered list. We refer to that as ordered list, OL. And these are generally HTML tags to refer to ordered list, to refer to um, unordered list as well. There are lists that are ordered, there are lists that are not ordered. So you have different types of table. For example, here you will see that this is normally a table where you have product price. You can scrap these data because they are structured. These are easy data to scrap, by the way. When you have data that are structured, it becomes easy to scrap such types of data, like here, which is an ordered list. This is an UL, which is not necessarily ordered. You can scrap these data without any trouble normally. That would be easy. So the short answer, as I said, is website scrapping only for structured data? No. You can scrap easily structured data, but when you can also scrap semi-structured data. Semi-structured data, there are certain things like cards that exist on, for example, if you go on Coats website, you might have different cards where you have images of a particular products and the price according to that product and so on, and information pertaining to that product. These are referred to as cards. You can scrap information from that as well. You can scrap information from meta tags, from JSON linked script, and so on. You can extract information, by the way, scrap these data without, um, not without, but it's a little bit more demanding than scrapping structured data. You can do that as well. You can also scrap unstructured data like a text. If I'm telling you I'm doing the module data mining, data handling, and analysis, you can also scrap such data, which are referred to as unstructured data. These are free text. You can still scrap these data for different reasons that you use. You want to apply these different you want to apply different techniques to analyze such type of lengthy text, for example, using NLP or natural language processing and so on. You are able to do that kinds of thing normally. You can even scrap image files. Like for example, here, let's suppose this is an image file with details like of a person, John Luke, data analyst, his number, and his email. You can extract information from image file as well, or PDF and so on. But then you have to be careful there. That will require something that we call an optical character recognition tool to be able to convert these image to text, and that would be generally very noisy, which means very messy sometimes. Okay, you don't expect necessarily when it is an image. This is an image file, not necessarily a text. Maybe you're not seeing it properly as an image, but let's suppose this is an image file. Getting this information like the name, the profession, and so on is not necessarily something that is easy from an image or a PDF file. This is why I'm saying that you might require optical character recognition, and it does not always turn out well. Okay, so these are the kind of things that you have to understand when you are scrapping data. Generally, structured data is the easiest to scrap when it comes to table, when it comes to OL and UL, OL ordered list, unordered list. You are able to scrap these without any trouble most of the time. Very easy. Semi-structured a little bit less direct, but it's okay. You can still do it using JSON file and so on. But unstructured data, it's okay. You can still scrap that, but non-HTML is relatively difficult sometimes. So what are we going to do next? Now we are going to talk about different storage techniques, and we'll talk about SQL and everything now. Before I talk about data storage, as I was mentioning, sorry, I forgot something. I want to give you a small example of how I can scrap a data in R. It's going to be a very brief and simple example. I'm not going to get into the details of everything that I'm writing right now in the R code, because in any case, we are going to discuss that next week in a different video. But just to give you an indication of what I'm referring to as scrapping. Okay, you recall, for example, I add this. You will see that I add this website. I can scrap certain information from my own website. That's why I make it legal by scrapping information from my own website. Okay, you have a website here where you have my information that I have here, I mean the interactive display that I've created. You will get this website, and I want to scrap certain information from that website. First of all, we'll open R. I'm just going to be relatively brief. I'm not going to get into the details as I repeat now, because we'll discuss that in due time. But first of all, I'm assuming here that you have all downloaded R and at least have studied a little bit about R. Please, it is important that you get acquainted to R. I've given you a support on Google Classroom where you can basically study R on your own. This is very important that you get to know R, because otherwise you might get some trouble in the forthcoming weeks. Of course, I will help you to the best of my ability, but it is still important that you know how to know R on your own as well. So I've given you two materials in any case. You can go through that and learn it independently so that you know how to use R. So what I will do, I'll create a new script in R. I'll tile horizontally, and then I'll write my codes here. And then this one, I will improve the screen size. And I'll start writing my code. To be able to scrap a data in R, as I repeat to you, I'm just doing that as a demonstration here. I'm not going to take too long to I'm not going to take too long to explain whatever I'm writing here, but uh, I will need to I will do that in the forthcoming session next week. So here what I'm doing is that I'm using a package in R called RVest. For you who do not have RVest, you will need to do the following. First, you will need to download the package using that code, and then it will lead you toward a pop-up where you will say, let me just show you that for those who don't have it. I will run that part here and show you what it gives. It will give you something like that. You just click OK and it will work. Okay, you click on cloud, you click OK, and then it will download the package. I'm not going to get into the details here, as I said. I'm going a bit fast, but for me, given that I already have it downloaded, I don't need to do that again and again. The only thing that I need to do each time I'm going to use that package is to write down library, which is like loading the package in R. So what I want to do is to read the HTML link, all right, to read the content of the HTML link. So first of all, I need to describe the page. The page is obtained by reading HTML, and then I need to give a link. The link is here. This is a link to the HTML file. I copy that link and put it in between inverted commas. That's the first step. And then my first step would be to extract the headline text. The headline text. So what do? I do headline, and then I say page. I will use a pipe. Now, what I just wrote here is an important concept in R. Piping is very important because it makes the flow of your writing easier to understand what's going on. Now, what is this operator here that I've written? It's normally takes the output of one function and passes it to another function as an argument. It takes the output of one function and passes it to another function. So the information that it has from page, it will pass it to something that I'm showing you in a moment. And it goes on like that. That's what it means by piping. So what we are doing here, I'm doing piping page, and I pass it to HTML element h1, and this as well I'll pass it on to HTML text2. If you don't put that text2, anyway, I will discuss that in next week, but I'm just showing you a quick way of how you can scrap data in a very, very simple way, how you can extract data. But in brief, the HTML, what I've written here, this function, normally it returns the HTML structure of your date of your page. It returns the HTML structure, which includes the tag, attributes, and all different things like content and so on. But when I say h1, it means that it refers to the HTML heading tag. It's an argument that I pass on to say HTML heading tag. Generally, this h1 tag in an HTML file is generally what refers to the header, right? It contains generally the main title or more important heading on a web page. Unfortunately, I'm not unfortunately, but I'm not going to get into the details of what a web page is about. It's not the purpose of this course. We are not here to do that, but at least we need to understand the basics here. If you want to call the header of a web page, you can usually use this h1. That will help you. Then if you don't pass on this next step, which is the HTML text 2, what will happen is that it will give you an unreadable information with regards to that page. For example, let me delete that and I just run these things. You will see that it won't be something that is easily understood to us. All right, you will get something like that. This does not mean much to us. To make it something human readable, I pass this on to the next step, which I pipe this to HTML text 2, and then I run that, and then now I can call headline. I run it, and there you get the headline, which tells me is web scraping only for structured data. You get the information of the headline that was on my data. Is web sorry. Let me get back to the web page rather. You will get the information is web scraping only for structured data, which was the heading, all right, in my data. Now I can also extract, for example, how do we say, ordered list and unordered list if I want in that data. For example, I can extract these information from my web page, and I can extract these information from my web page. I'll just show you how to do that quickly in a matter of seconds. So what we will do is we will say ordered. I want to extract the ordered items. So what I do is, again, I need to use page and use a pipe operator. Pipe operator, and then I will use HTML element as usual. And then in the HTML element, I can't use the same argument that I wrote here because this is to extract the header. But now if I want an ordered list, I type OLLI. OLLI means it will go in the document and extract any ordered list that you have. For me, you already know what is the ordered list that we have. And don't forget, you always need to pass on this information here so that you can read clearly what's going on. So, and then I will run that part here. I run these two, and you will see that it gives me Outfield Jackson, Atlanta, the first ordered list. Let me just check that. Jackson, Atlanta. Okay, that's what it gives me, the top airport. If you want the top airport, you can get these information that you have here. If you want the full list, I forgot the S here, then you will need to do HTML elements, and then you run this and you get all the three different list that you add. You will see here, these are the different names that are extracted from the website. Of course, why are we doing all that? Is of course for the purpose of analysis later if you want to do something with that. I show you now how you can extract the unordered list if you wish. Just give me, yes. If you want to extract the unordered list, how do we go about extracting the unordered list? We can just type unordered item here. Unordered item, and then we are going to repeat the same process here. But the only difference is what? Is that instead of the ordered list, we will use the unordered list. And don't forget the S. If you don't want only the first, you will need to get the S, and then you type the unordered items down there. And then you run that. You will see that it will give you a list of 2 cups, 1 cup sugar, 3 large eggs. So it is reading this information. So what you just saw here is that I'm scrapping my own website, my own information, and you can see how it works. By the way, you can try it yourself later. You will see that it will work automatically. But scrapping other information is relatively difficult. I'm not going to discuss that right now. But in any case, I will discuss a bit about web scraping and SQL and so on in the next lecture. So now I can talk about storage. When we have captured the data, we obviously need to store that data. Okay, and in this class, we will mainly refer to what we call a relational database that is used to store a data. When I talk about the concept of relational database, what normally do I mean by a relational database? Let me just give you a small example for you to understand. Basically, when I refer to a relational database, I'm referring to data being stored in multiple related tables. Instead of having only one flat file, one large flat file, for example, a CSV single file which contains all the information, you have several different tables that contain information that are related to each other. An example I might be using is, let's say, for example, uh, let's suppose I'm talking about a small library. You are the manager of a small library. If you are the manager of a small library, there are different information that needs to be taken into account. Okay, what are the different informations? For example, you might have different tables that relate to different uh, information. For example, you might have a book table. Just give me a second with you. I'm getting a small issue with my Wacom tablet. So you have a book table. You have, for example, a member table, and you might have a borrowing record table. Let's call it borrowing. Then in the book table, what would you have? You will have several other informations, like for example, in the book table, you will have a book ID as one column. You will have a title of the book. You will have the author of the book. You will have other things, the category, book ID 1, book ID 2, 3, the title of those different books, and the authors of those different books. That's an example of a book table. Then you will have member table. Now, when we talk about member table, you have member ID, and you have, of course, the member name. You have other maybe email address and so on. All right, you have these different information that you might have in this table: member ID, member name, member email address, and other information may be related to the member, where you have member 1, member 2, member ID 1, member ID 2, the name of that person, the email address of that person. Then you might have a borrowing table. When you talk about the borrowing table, you will see that in this particular context, for example, in the borrowing table, you might have, for example, the borrowing ID, the member ID. You need to know who wrote the book. And let me just do that on the left because I'm not getting sufficient space. Just give me a second with you. You might have, for example, when we talk about the borrowing table, I have a borrow ID. I have, for example, the member ID. I will have the book ID, for example, because when I'm the first book borrowed, the second book borrowed, the third book borrowed should be related to a member ID. For example, member ID 2 has borrowed the first book, member ID 5 has borrowed the second book, etc., etc. What book did member ID 1, member ID 2 borrowed? Maybe they borrowed book ID 5, which is not written here, but book ID 5. Maybe the second borrow ID involves member 5 with whatever name and email, and borrowed whatever book that you have here, maybe book maybe 1, for example, and it goes on like that. You get a list of different tables where now those different tables, they are linked together. For example, book and borrowing are linked through their book ID. You will see that both of them have a book ID, and you will see that members and borrowing are related together by member ID. So they are linked somehow. That's what we refer to as relational databases. So you will see that, for example, each of them have different keys that I'm going to mention without getting into the details of it now, because in the fourth week we shall discuss all this in detail. So right now, I'm just telling you what a relational database is. You will see that instead of having only one flat file with all this information like name of member, member ID, old name of member, book borrowed, and so on and so on and so on in only one single file, one single table, it is preferable to organize it like this for different reasons, obviously, for simplicity, for the purpose of efficiency, and many other reasons that you would want to do that. So this is an example of a relational database I just gave you, and it's a very important principle because normally when you have captured your data, very often you would like to save this data in a relational database as far as possible. Of course, as long as it is structured data, as I mentioned to you in my previous classes, my previous class rather, if a data is not structured, we have to be careful. There are concepts like data lakes that comes in that we are not discussing necessarily in this course, but we will focus mainly on relational database, and we will use the concept of SQL to illustrate all that. But before that, let me just give you an idea, a quick view. I'm not going to read that with you. You can go through it on your own, but just a quick overview. When we talk about a relational database, it is a type of database that stores and provides access to data points that are related to one another. Okay. Now, when we talk about database, it organizes data into one or more tables of columns and rows with a unique key identifying each row. Like you would recall in the previous example that I just mentioned, you have borrow ID is a unique key for the borrow table. Member ID is a unique key for the member table. And book ID is a unique key for the book table. So that's what I mean by keys, all right? So, for example, when we talk about relational database and so on, you will see here, normally you will have tables that are made of rows that we call tuples sometimes, and you will have the columns that represent fields, all right? The rows are also referred to as field, or here we refer to them as attributes in this particular context. For example, ID is an attribute, username is an attribute, email is an attribute, and then you have the tuples here, which contains the different information for these different attributes. Then there is a concept of ER diagram, which represent the blueprint of a database, the schema, which represent what is the schema? Normally, a database schema is the design or structure of a database. It represents the design, the schema represents the design or the structure of a database, which will define how your data is organized and how these different data elements relate to each other. All right, that's what a schema is about, and it can be represented diagrammatically through an ER diagram that we will discuss in the fourth week. This is an example of an ER diagram, an entity relationship diagram that we will discuss later anyway. And then, as I mentioned to you, in a relational database, there is a concept of keys and constraint, where you have primary key, foreign keys, and other types of constraint that exist, unique constraint, not null, check, and default. All these are different constraints that exist. I'm not going to go through that one by one. You may read that before you come to the lecture 4 to get an overall picture of what is going to come. And then you have, of course, how different tables connect to each other. There is the 1F, the NF, and all these different concepts that shows how data, how different tables connect to each other. All right, there is a one-to-one principle, there is a one-to-many, there is a many-to-many. All these are different things that we will discuss anyway again in the forthcoming weeks, not now, but in the fourth week. And then you have the concept of acid properties. That concept of acid properties is quite important. This is a key feature of systems like MySQL InnoDB engine. What is this MySQL InnoDB engine? Basically, it's the storage engine, if you want, for MySQL. It is the storage engine normally for MySQL. It's what will enable your data to be stored in a reliable way and will also be performing well. Right, that's the idea behind the InnoDB. It's just a storage engine that is used by MySQL normally. So, having said so, I'm not going to get into the details of all these, but basically, it's the engine that enables you to save your data, and this engine, the InnoDB, abides by this property of acid. What is this acid? It means there is atomicity, there is consistency, there is isolation and durability. All these are concepts that needs to be abided by when you are working with SQL and so on. So the principle of atomicity, for example, I just mentioned it quickly, and then you can go through it yourself because, as I said to you, we will be probably well, not probably, but we will be coming to all these concepts again in the forthcoming weeks. When we talk about atomicity, we are talking, for example, let's suppose I'm making a transaction online for on Juice, for example, or on any bank application. I'm doing a transaction. If when I'm doing the transaction, let's suppose I saved my money, I'm depositing a money, or I'm transferring a money from my account to a different account, I'm transferring money. If there is a failure somehow, let's suppose, we need to ensure that let's suppose I've made the transfer, I've withdrawn my money, the money needs to be received by the other person that I've transferred the money to. It cannot happen that when I'm transferring the money for whatever purpose, that there is a failure in between, that the money did not reach the account that I had transferred. So it means transactions are all or nothing. If one part fails, the entire transaction is rolled back. That is the concept of atomicity. So there are other concepts that you can read, and then you have also SQL, which refers to structured query language that are used to query databases. All right, and what are these different commands? What are the different queries that you can set in databases? They can be organized in terms of data definition. They can be organized in terms of data manipulation, data control, and transaction control. When we talk about data definition, for example, there are certain queries that you can set to uh, to query your database. That is, for example, you can create a table using the term create. You can alter a table using alter table. You can drop a table using drop, or you can drop a database as well, a schema. Then you have data manipulation, where this select statement is a very important statement that is used. You will see, I'm going to discuss that in a moment, but it's a very important statement that is used in SQL. And then you have insert, update. All these are different commands that you can run in SQL to be able to query a database. I will show you in a moment the practical aspects so that you get a better idea of what I'm talking about. Otherwise, all this will be just abstract. Okay. Of course, I'm not going to go in all these now, just give you an indication. In any case, we are going to come to that in the forthcoming weeks, as I mentioned. So I'll give you a glossary term here just to define a few things. There is one thing that I need to remove here in any way. I will get to that afterward. Now, Let me just go directly into what you need to do. I would require you to do that, please, just to make things easier. So, what you will need to do at home, this is what we are going to use. You need to go on Google and search MySQL. Go on Google and search MySQL. Search MySQL. Then you click on MySQL. When you reached MySQL, you will see that there are two things there that I would be interested. There are many other things that I'm not interested in. We will be mainly using these two in this course, the MySQL Community Server and the MySQL Workbench. So you will need these two. You click on MySQL Community Server, which is basically where you are going to save your data, and then you will need to come back there and go to download, and then in the section of download you click on MySQL Workbench. When you click on these two, you will see that we will need the both. We will need the server where you are going to store your data as such, and then you will need the MySQL community download, which is sorry, not community download, but rather the MySQL Workbench, which is the interface that will enable you to query your data in your community server. That's basically the idea behind. So what you would do is that you will see that there is a latest version, the 9.4. You just download that based on your operating system, and you will click on the first one, x86, depending on your computer. I guess this would be the case, x86. You click on download, and then you follow the instruction. You just say no thanks, just start my download, and you follow the instructions there, and it will be relatively easy. I will send you in a few when I finish the class, I will send you um, an an instruction on how you can download it if in case you are getting trouble in it. Then when you have downloaded that, the next step is to download the Workbench, which is the interface that enables me to work with my database. And you just click on download again. When you click on download, you just follow the instruction. And when you will be required to put a password, I would kindly request you for the password to use a password of ABC123, so that when we are doing the class, you know that if one day you are um, if there is any issue, you can still use that password ABC123 as password for the class. And then when you will reach that point, you will understand when you download it, there will be a moment that it will require you to put a password, and that password that you will put will be ABC123. I suggest to you, of course, if you want to use another password, you're most welcome to use another password, but ensure that you remember the password, because if you forget the password, you will have to some trouble working with SQL, especially in the forthcoming weeks when we are going to connect R to SQL. So this is why I'm reminding you, please use this one if you don't want to get into trouble later. As far as possible, just a basic one. Having downloaded these two, you will come up to something like that. So you can already do that this week, and then next week we will get into some practical aspect of all these. Then you will go in your start menu and you will identify the workbench, and you will open the MySQL workbench. The community server, you just follow the instruction that I'm going to give you later, and then you go on MySQL workbench. When you go to MySQL Workbench, there will be an interface that will appear. Just give me a second with you. This is going. This is what you're going to see normally. You will see something like that. And here you will have different databases that exist. For example, me, I've worked on certain databases, and then there are some that are default when you're going to install. For example, you will see SYS and World are default databases, and there are other databases. So what I want to do is to click on plus. When I've clicked on plus, just for the sake of time, so that we don't take too long, I'm just going to copy and paste an example of some codes that I've written for you to create a small database. So I'm not going to get into the details of all these codes, obviously. We will get into that next week. I'm going to explain how to create a database, but just quickly, you will see that here there is normally a series of databases. And let's suppose, not let's suppose, but we don't have a university database. What happen is, what I will do is that first I can create the database university. When I create the database university, you refresh that navigator panel that we call that, you will see university appear here. Now, to be able to use a database and work over it and query there, you need to click on Use University. You select and click on Use University, and you get it. I will give you the codes in a few minutes. You can play around. I will give you the codes rather when the class is over, so that you can play around with that. It will work perfectly well for you, and you can, when you have already used university, you will see that the table is empty. There is no tables in this university. If you click here, there is nothing. To be able to obtain something, you can create a table using these different codes that I'm not going to explain now. As I said to you, it's not the purpose, it's just to give you an introduction. So I click on refresh, and then here we go. We got now a table that exists. When you click on that drop down here, you see that there is a table that exists, and there are different columns that are included: full name, undergraduate program, year of enrollment, GPA, and so on. Then you can insert some data in there using the insert into function. And you click on insert into function, you click on refresh. And when you click on refresh, when you run that small select statement star from master's table, you will now observe that the data has been populated here. In the database, you've got the data Matthew Isaiah with whatever degree, and so on and so on. And then you can also do other things like simple filtering example, where you select the particular name of students with a particular GPA. So you can select only one column in that database, in the table rather than database. In that table, you can select only one column. And in that column, I'm interested in only people whose GPA is greater than 3.8. I can just run that, and you will see that these are the only two people whose GPA were greater than 3.8. Then you can also select people according to, from the table you can select all the columns. When you see this, it means all. Select all the columns from the master's table whether your enrollment is 2024, and then you will see that only two rows are given because there were some people who were 2023, 2022. So these are the only two rows that were returned. These are the different things. You see these select statement, you see the where, you see the insert, and you see the create, for example. All these are the different keywords that are used. Let me just open the, yes. Like here, you see that there is create. There are other things that you will learn anyway later. I will get into all this, of course, in details later when we come to next week, where I will talk about SQL. But in the meantime, you can still download the SQL and the MySQL Workbench and the MySQL server, and we're going to use that next week. So that's a little bit the concept of what we call relational database. All right, that's the concept of relational database that I wanted to discuss with you. And now, having discussed the relational database, it is also important to understand the different format of data, the different format of data that are important to discuss. When we talk about file format, it's very important that we understand what are the different file formats. I will focus mainly on, I will not focus, but I will work mainly on three file formats here. We will talk about CSV, we will talk about uh, JSON, and we will talk about Parquet files. All right. So we will start obviously by CSV, and then we'll talk about JSON, and then in the end Parquet. To start with, let's start by JSON, CSV, sorry. A CSV file, basically, I believe that most of you are already acquainted with that concept of CSV. But I just give you an example here. I've got a file which is .xlsx. That is, this is a file which is an Excel file. This is a data set that I have got, and it is in Excel format. What I might want to do is to save that file as CSV to be able to read it in R most of the time. Very often, data come in CSV format. When you go on open sources, you will see that the data, they don't come necessarily in Excel format, but they come in CSV format. They look a little bit alike, but they are not the same as such. No, because the CSV format, which calls comma separated values file, it's basically plain text. What do I mean by plain text? You see, for example, here there are some formatting. This is in bold. For example, the header, you will see that there is an underline just below the header and so on. There are some formatting going on in the table, basically in an Excel file. Sometimes maybe you will have formulae that exist as well in an Excel file. So what you want to do is you want to use it as CSV rather than using the Excel file for for running and for applying an analysis in R, for example. What you want to do is to convert it to CSV because CSV has got some advantages. For example, you will see here there are different advantages of a CSV file, what they are about. Okay, they are simple and compact, they are human readable, they are universal, they are in the form of a spreadsheet, very easy to understand. Though they don't have a data types, it cannot. I mean, they don't have a data types. They don't distinguish between data types. For example, when you're going to save that file as CSV, you will see that it doesn't necessarily have a particular data type. I'm just giving you an example here. You can click for another example of a data file that I've posted on Google Classroom that you will see exist here. You can download a CSV file. You will see it's already in terms of CSV. That's another file, but I'm showing you another file which is in Excel format. And this file that is in Excel format, sometimes you might want to convert it into CSV to make it a flat table without uh, any formatting or anything. So if you want to convert the data into CSV format, you can say click on File, Save a copy, and then you change that Excel workbook as it is right now, the extension. You change from XLSX, you change it to CSV, comma delimited. You will see it here, CSV, comma delimited. You click on CSV, comma delimited, and you save the file wherever you are interested in. Let me just find the appropriate path for that. I just took an example from a different course. Let me just show you how it will come, how it will become. Uh, Sorry. You save it somewhere, wherever you want. You save it, and you will see the result. I save it as CSV. When I save it, remember how it looked like before. And now when I'm closing that and I'm opening the file again from where I've saved it, you will see in a moment what will happen. Just look at that. You see there is no filtering, there is no underline, there is no bold or anything, it's just a plain file. Now, removed any formatting or anything. That is very good basically to use a CSV file whenever you have to work in R. It's always advisable to convert your Excel file, if ever you have an Excel file, to CSV format when you have to work in R. That's a very good practice. Now we move on to something more important, the JavaScript object notation, which we refer to as JSON. JSON file is also a it's a semi-structured data file. And this kind of data file, I told you earlier. You get it from APIs, you get it from websites, and so on. You get these kinds of files very often. I want to explain to you. You can read all these later. Let me just give you an example of how a JSON file look like. You can click on the example. It will lead you toward your Google Classroom that will give you an example of a JSON file. There are many things that you will see. There is a square bracket, then there is a curly bracket, you have inverted comma, and all these different information that you see here that is in the form of a JSON file. Very often it is characterized by this curly bracket that you see very often. Now, what are all these curly brackets, square bracket, and what are all these different information that you have in a JSON file? Maybe I will start by explaining to you how you can create one so that you understand what a JSON file is about. Let me explain to you how you can create a JSON file, number one. Then you will understand it better because this is important. You will need to know how to use a JSON file, and you will also, it's also part of your assignment, by the way. You will need to know how to create a JSON file. You will need to understand what are the different components of a JSON file as well. Okay, so just give me a second with you while I'm organizing myself here. So let's start by first thing. When you are creating a JSON file, you will see that you can create a CSV file and save it as CSV. But you can also create a JSON file yourself, even without, it's not with an Excel file. You won't be able to create a JSON file for an Excel file, but you can create a JSON file in different ways. All right. If you have Visual Studio, you can do that in Visual Studio. There are many ways that you can write a JSON file, but you can also write it in a simple notepad, as you saw me opening here. A notepad. You all know what a notepad is. You got it easily available in your uh, on your computer. I'm going to tell you how you are going to create a JSON file, and then from after having created the JSON file, I'm going to explain to you how you can read that file, how you can read that file in a structured way in R. Briefly, bien sûr, because I will get into the details again next week, as I told you. So I'm just giving you an overview. First of all, when you are talking about a JSON file is generally, how do we say, it's a way of organizing data. Okay, it's a way of organizing data. The entire block of code is generally what you're going to write in your JSON file is generally enclosed in either square brackets, or they will be enclosed in either curly brackets. All right. When we talk about square brackets, the square bracket generally refer to what we call arrays in the context of a JSON file. It's an array that we refer to that. I will explain to you in a moment what an array is in a moment, but I'm just mentioning the terms right now. The curly braces, they are here to represent an object, a single object, an object. That's what the curly braces are meant to. So what do we want to do? I want to create a data using JSON format where I will include the name of an individual. I will include the age of that person. I will say if that person is a student or not, and the skills that that person has got. For example, you yourself, I want to record your name. I want to record your age. I want to record whether you are a student or not. I want to record what are the skills that you have, for example. So, what I want to do now, to be able to do that, I will start by recording the object that I mentioned here, the object. And in that object, it will contain different components. Okay, there are different components that it will contain. What are the different components that it will contain? For example, it will contain the name. It will contain the name. of a person. For example, what is your name? I will explain to you in a moment. Let's suppose I take the name Ruben again. So it will contain the name of a person. It will contain the age of a person. Let's suppose I'm just making up a value. Let's suppose 18. And then if that person is a student or not, let's call it like that, is student. And then that person, let me come to that afterward. Let's suppose that person is a student, yes or not, but it will be referred to as false or true because this would be a boolean. We refer to that as a boolean data type. I'm not going to say yes or not, but rather I'm saying true or false. And then you will have the skills of individuals, but that I will talk about the skill. Let's suppose that person knows R. All these are the different information that it will uh, include, but you can't write it like this. There is a formal way of writing all these different information. I'm going to explain to you now. Normally, the JSON the JSON structure is like that. These curly brackets represent what we call a JSON objects. Now, in a JSON object, what you will happen, the JSON object will contain a collection of what we call key value pairs. Key value pairs. The JSON object normally will contain a set or a collection of key value pairs. What does it mean by key value pairs? What do I mean by that? The key value pairs. When I talk about a key value pairs, for example, you will see that the first thing that I want to include would be the name of an individual. For example, I want to include the name. A way of putting down the name here would be not to write down Ruben only, but I will need to say the key, which is name, and then I put a column and I enclose the key within inverted comma. I include the key within inverted comma. If I want to record the age, I will have now age as a key, and the value would be the age itself. For example, when I say name Ruben, we have a key value pair which contains the key, which is the name. We refer to that as the key, and the name is Ruben. The name is Ruben, that is, the value is Ruben. So you have here a key value pair, and generally, when you are going to include multiple key values, what you will do is that you will put comma each time. So I repeat, when you talk about a key value pairs, it's always going to be like this. Note something, that a key is always string enclosed, as you can see here. The key is always, I repeat, always string enclosed. However, when you are referring to the value may be a text. The value is, let me tell you what are the different values that you might have. You might have values that are strings. What does string? Basically, strings represent text. Normally, that's what it means. Like, for example, the name Ruben is a string. And each time when you are referring to a string, it has to be enclosed in between double quote, uh, like this, inverted comma like that. All right. When you are referring to a string, always, in fact, in almost all software, when you are referring to a string or a character text, you have to enclose it within inverted comma. That's one thing. But the key value is always inverted comma. Now, when it comes to age is a number. That's another type of value that exists, numbers. All right. A number can be a decimal, can be an integer. And this, you will see that I don't write it within quote. It's just without quote. All right. It's without any, I don't write them between double quotes. They are not needed. When you are referring to a number, it's just normal. Then I wanted to show you another data type for that is student is student. I have now another key is student. Remember, when you are writing a key, which is like a variable name if you want, is student, you will need to say if it is true or false. Let's suppose false. That person is not a student. So if that person is not a student, then what happened? You would put false. False represent what we call Boolean, a Boolean data type, or not a Boolean value rather. And this Boolean value can always take only two possible things, true or false. It can't take more than that. So again, here you will see that this is not necessary to put in between inverted comma, because if you put that between inverted comma, you will treat it as a string, and this is not what we want. We want it to be treated as a Boolean, which is a character that can take only two possible values, either true or uh, false. And then, of course, there is another type of value that exists. Let's talk about skills. The skills that these people have got, that person has got. Now, when we talk about the skill, if I say that the person knows R, that's all I'm going to write, because R is going to be normally a string here. But let's suppose now I tell you that the person does not have only one skill, but has got several skills. If that person has got several skills, I will say, for example, R, SQL, Python, and so on. All these between inverted comma. I repeat, whenever you are dealing with a text, you will put that between inverted comma. Maybe that person knows other things like C++ or whatever it is. Okay, let's stop here. For example, in that particular context, whenever you are writing the skills, and if you have several skills, you have multiple values that needs to be included, a list of values, then you can't write it like what I'm writing here. You need to enclose that within the square bracket. When I talk about a square bracket, and this is what I refer to as an array. The array basically is a list of values. A list of values which is enclosed in between square bracket. So here you will see a list of values. When I talk about values, it does not necessarily mean number, but it can refer to a text, it can refer to all these. So that's how you are going to input a data in JSON format. You are going to input a data in JSON format a little bit like this. Now here you go. You got the person name. You've got the name of a person, Ruben, age, and so on. And then you can stop here, and then I can save that file. And then I can, when I've saved that file, I can open it in a browser, or I can open it in Notepad itself just to see how it looks like it is right now. But I can also open it in a browser to get a little bit a better feel of how it looks like. I will show you that in a moment. But first of all, how do you save that file? When you save that file, you say do save, and then you will come here, and then you will say put the name of the file. For example, I want to talk about the name of a file is, let's suppose, Ruben JSON example. Ruben JSON example. When I wrote Ruben JSON example, to ensure that this is saved as a JSON file, I should not leave it like that and save. I should put an extension by doing .json. When I put .json, then the file will not be saved as a text file as you see here, but it will be saved as a JSON file. There's a difference. So to be able to save a file as a JSON file, it's important that you include that .json at the end, and then you click save. When you click save, it will you will see it somewhere here uh, in your folder. Just a second with you. I'm trying to locate the file. Here we go. So I'm going to show you quickly. You will see here that JSON file has been loaded, ruben.json. You'll see that this is not a text document anymore, but it is a JSON file. So what happened here? is that if you want to open it, you can come here and right click on it. There are different ways of opening it. You can open it double clicking on it simply, and you can open it in Notepad. It's just the same thing that you just wrote. There's nothing much. We'll close here. I close that. Or you can also open it in terms of based on a web page. You say open with Firefox or whatever you have. Maybe not Firefox. You can open it with Google Chrome or whatever. But like I like Firefox in that particular context because it gives you a neat uh, view of the JSON file. You see now you can click on that. You see that the file contains name Ruben, age 18, is student false, skills. You will see that you can click on that drop down and you get the different skills 0, 1, and 2, these different skills that he has. So that's how you can open the JSON file if you want. Now, let me do something additional to what I've just done. I open it in Notepad again. I open it with Notepad again. That same example that I've just worked on. When I open it in Notepad, that's very good. Now, let's suppose I have now another person. Let's suppose I'm recording all your information in the class. There is someone calling name Ruben in the class, but there are many other people in the class. So if there are many other people, maybe I will have kind of similar information. I would have some kind of similar information. The name of a person will be probably John now, and he will be maybe, let's suppose, 40, and maybe his student, yes or true. I may also remove that. There is no need for that particular variable. Maybe that's the advantage of JSON here, in the sense that it is flexible. You may wish to disregard that as well if you want, or you may also include it if you wish. That it's up to you as you may want to do. And then you can include the skills of that person. Let's suppose that person knows a bit of HTML, knows a bit of other software like R as well, and that person maybe knows only these two. Let's suppose. Okay, that person John knows only these two. So you record only these two that he knows. But the only thing that you have here is that when you are putting an object, remember that this is a JSON object, and the JSON object you have a key value pairs. Like in this one, this is a second object with different key value pairs. You always need to separate it by a comma, depending on how many you are including as names. The more names you include, each time you will put a comma every time. But if you have only these two names, you have only one comma here that separate these two uh, objects, but it's not sufficient. If you run that, you will see that when you save this as it is here and you have tried to open it in uh, the web browser, it may not work. It may not work, it won't work. To be able to ensure that you include a list of objects now, you always need to start in this particular context by the square bracket. So you see the importance of a square bracket. Whenever you have a list of objects, a list of key pair, a list of values, for example, a list of values and so on, then it is always good to put this square bracket that represent, we refer to as an array. So when I'm done with that, I can save the file again, and then I can close it and open it again from the web browser. You will see a little bit something a bit different now. You will see that now you have the first individual name here. You have name Ruben, age 18, is student false, and then dot it doesn't give you everything. If you want to get everything, you can open that, and then you can start having a look at what are the different information that you have when you are opening the JSON in the Firefox. I think it should work also for Google Chrome, but I'm not sure if in Google Chrome you will get the same kind of thing. In Google Chrome, maybe you will get it in that form like this. All right, but in the Firefox, I like to open it there. You get the different information through drop downs like this that you can check. Okay, those are different information. So, this having said so, what we want to do now is to read a JSON file in R. Now, this is a very simple example of how a JSON file is. You can see a simple example of how a JSON file is, like this. But what you want to do now is to be able to read that kind of file in R for analysis purposes. You can't analyze the data like that in R as it is right now. You need to convert it into an appropriate format to be able to analyze it in R. So how are we going to do that? We open R. I will just open a new script. To be able to open it in R, I'm just going to be very quick. I'm just going to copy and paste my code here so that we don't take too long. Because anyway, I will explain that to you next week. Don't you worry. If you don't have a package JSONLite installed, you remember I was mentioning a parser earlier, parser. So this parser is what the JSONLite is about. The JSONLite is a package that enables you to convert whatever data that you have here into an appropriate format in R that you can analyze. So you can run the library JSON file when you run JSONLite, sorry, and then you read the file by using this function from JSON. You read the file. If it is an extension of JSON, you put the name of the extension, ruben.json, at the end of a path. And then when you are done with that, you can look at the data quickly. And then when you print the data, you will see the name, age of a person as it is. And you've been able to see that using this package JSON from JSON, you can easily call the data into a structure that makes it a little bit easier to analyze. For example, you can also view data. And then when you view data, you get the name in the form of a table, the name, Alex, age, is student, false, no, and A not applicable. You remember because we did not put we did not put this information earlier for John. That's why it is. Yeah, I'm using a different example. I'm using the example of Alex, but you get an idea of um, what it looks like. So the person has got the same skills, for example, in this particular example. So you see that you can easily come and put that in R, and from R you can do whatever analyzers you want. Of course, for such types of situation, it requires some further manipulation, but at least you know that you can read a data from a JSON file in R using this JSONLite package without getting into much details. Obviously, now I'm going to talk about that next week when we are going to do the practical session, of course, on the video. So that's a little bit about JSON, that what it is. Of course, you can read through that to see the disadvantage and advantage of each of these. And I already told you what the JSON file is about. You understand how to create a JSON file. You understand how to read a JSON file from in R rather. You will also see that I've given you an enhanced interactive JSON explainer to illustrate a little bit these different keys concept. Okay, you will see here the different concepts. You will have the objects, the arrays. When you hover your mouse over these different components, you will understand what these are: string values, numbers. I've already been mentioning all this, but you have a formal way as well of discussing that for revision purposes. This is an object, I explain to you what an object is and so on. So you can go through that. I leave it to you, obviously, to do that yourself and check what you've got there. Okay. Now, the Pocket file is another very useful and powerful file, the Pocket file. It's a very powerful file format, in fact, and it's especially useful when it comes to working with really big data. It's very useful when it comes to really big data. Generally, when we talk about JSON file, we get it into web applications and so on, even in HTML files and so on. CSV file is okay, it's fine. You can work with relatively big CSV file. But when you have data files that are exceedingly large, extremely large, let's suppose in terabytes, all these kinds of things, it is not necessarily convenient to use CSV files and so on. It's better to have your files stored in JSON form, not JSON, sorry, but Parquet format. Because Parquet format is a columnar storage format. What does it mean? It organizes your data by column instead of by rows. You might ask yourself, what's the difference between a CSV and what's the difference between that when you talk about arranging your data in terms of column? Let me just give you a small indication. You can read the pros and cons on your own. Let me just give you a small example to illustrate what I mean. We'll click on that interactive Pocket Data Explainer. Suppose you have a data in that form. You have the different months, the different district, the tourist arrival, the hotel rate, the rainfall, the electricity consumption, and all these different information, as you see, are in terms of rows and columns. You see, this is what it is. If I ask, uh, if I have to run a query on my data or a search on my data, let's suppose I have to do a search on my data where I am interested in knowing what is the month with the highest rainfall. With the highest rainfall, what is the month in the highest rainfall? Oh, let's suppose the month with the lowest rainfall. Okay, what would happen is that when you are doing that in CSV or row column format, your search will have to go through each row, starting from month January. It moves to Quatre-Bornes, it moves to tourist arrivals 5,824, and it moves on and moves on and it goes to 386.9, and it goes on. It goes on like this. It goes through all your rows that you have in your data. Look at the way that my cursor is moving. You'll have to go through all the rows of your data one by one until it records which one is the highest rainfall. That's an example of how normally it would be in a CSV data file, for example, which is not a Pocket file. That's one issue that you have whenever you are dealing with big data. Doing such types of query on your data may take an exceedingly long time before you get a result, especially if you are dealing with, let's suppose, hundreds of, not hundreds, but in terms of 10 millions or even more than 10 millions of rows of data with different and several columns, let's suppose thousands of columns. It's not really a good thing to work with CSV format. Then it is far better to use the Parquet format. Of course, I'm not getting into the details here of how to create a file into Parquet, but I will still nevertheless show you how to read a Parquet file later. But as I'm mentioning here, going through all these rows, scanning each and every row just to obtain what we want is really not really feasible. So what does a Pocket file do then? The Pocket file considers each of these columns separately. That is, it keeps the month as it is, but it separates them. Look at that. It creates these different single columns, all right, all values from a single column together. That is, create each of these columns as a separate entity. All right, each of them are considered as a separate entity on their own. If I'm interested in what is the highest month with the highest rainfall, I just need to scan that column. I don't need to go in each of these rows one by one to be able to know which month is going to have the highest rainfall. I just need to study the highest rainfall column only. I will determine from that which is the highest, and let's suppose it is index 1, then I will know that it corresponds to the first index in month 1, and it's done. Very easy. So what happened is that I don't need to go through district, I don't need to go through tourist arrival, I don't need to go for hotel rate, electricity, and so on, just to be able to find which month is the highest in a very big data. You see, when the data, especially when the data is very big, that file format becomes very convenient, the Parquet file. That's just for information. So you can click on these different components just to get a description of what's going on here. When I talk about the rainfall, for example, here you will see all rainfall measurements are grouped into a single columnar block. If you wanted to find the month with the highest rainfall, the query would only need to scan this one efficient block of data, ignoring everything else. That's the advantage of the Pocket. So you can imagine how much of time you save by not going through all of these rows, through district, for tourist arrival, through average hotel rate, just to be able to read which one is the highest month of rainfall. So you avoid going through all these different rows. That makes things far more efficient. That's a little bit what the Parquet file is about. So a quick comparison between JSON and Parquet. You will see here. Let me click on that and just open the new file. So you click on that, you will see what the JSON is about. I already mentioned that. You can easily understand that JSON stores data in key pairs, key value pairs, and you will see, for example, here this is a key, this is a value. All right, and it goes on like that. You have, for example, how do we say? Nested structures as well. I did not explain that to you necessarily earlier. You have nested structures, for example, the profile of an individual, which is a key which contains the required information. And then you will see that there is recent comments as well, which is within an array, and the array contains other, how do we say, of objects and so on. So let's move on to this. For example, here, remember that if you want to know in this particular example how many add to cart events have happened, how many add cart events is there. You have a data set with event user IDs. You have their event type. If you view the page, they added something to the cart and so on. If you want to know how many add carts you have, then if this was stored in CSV format, you can imagine how much time that would take to read. You see, 1, 2, 4, 5, 6 rows that to scan. But the advantage of instead of JSON and CSV, the advantage with Parquet file that they are separately considered. So you will know just by looking at that block, that column, event type, you will be able to determine how many add cart there are without going through user ID, without going through device, without going through all these. Just a count can make it can become faster using event type, using the Parquet file format. So when to choose which, it depends on what you are applying. If you are building a mobile app and you need to get information with regards to the user profiles from that mobile app, obviously the data will be stored in JSON normally. All right. That's the way generally things are when you talk about mobile app, web applications, and all these are stored in JSON file. You have a 500 gigabyte data of sensor readings and need to calculate the average temperature reading across all sensors. Then obviously when you're dealing with such huge amount of data, it is for sure not appropriate to use CSV or maybe the JSON, but far better to use a Pocket file. That's how it is. So here we see the difference between these and which one to choose. As I said, it depends on your application. You can click on that. Can click on this interactive display, and it will give you an overall indication of how what file format to choose in what context. It depends, as I've already been doing, telling you these different contexts. The JSON, when you apply the CSV, is like uh, for example, the main purpose is quick and easy sharing when you are working with CSV file, of course, as long as it is relatively small compared to a 500 gigabyte files, which would be better for a Pocket. So for web APIs and configuration, you will generally use a JSON. When you have to collect data from web APIs and so on, you will use JSON. When you are dealing with, you have to deal with big data and you need to do fast and efficient analytics, you won't be able to use these kinds of format. It is better to store your data in a Pocket format to be able to do your analysis um, well. So I gave you some differences between these. You can read through that on your own. It's not complicated. Um, so that's a little bit what I had to explain to you today. So what is next for our next session would be basically an applied session where we are going to use R and we are going to use SQL to what to run a basic SQL select. We will do that next week. We are going to run simple SQL select statement. We are going to use to go through what I just explained to you earlier, but a little bit uh, more in details. Obviously, I'm going to go a little bit slowly on that part of how to create a table in MySQL, how to query a table in MySQL, and so on. I'll go a bit slowly. Today it was just a demonstration. So I'm going to go through that next week in the practical session. And also, I'm going to talk about how you can source open data, how to import data into R, if it is JSON, if it is HTML, how to do some basic web scraping, and all these different things that we mentioned today. So I'm going to explain the applied side of all this next week. That's all for today, folks. See you. Have a nice evening. Bye.